like probably 15 people on this call helped enable this workflow that I'm going to talk about. And it's a really common workflow. And so I hope you see some of your work in this talk. Many of you will. I'm working on this Coast Predict project. They've got models, ocean models running all over the world, and they produce netcdf files and they put them somewhere. And so like there's like 5 days of nets in each of these netcdf files, and they come every day. And so you have these big piles of files everywhere. And I knew we could do a little bit better. So a couple of months ago, though, after a post in the discourse forum on this cool X-ray indexes page, you look through here. There's some cool indexes that different things that people have built, and at the very end here, weather forecast cubes. Weather forecast cubes. So this is something Deepak did, and I'm just going to scroll down to this little picture here, and this is kind of the thing that we're dealing with. This is a super common use case where you have some forecast model that's producing a forecast for a certain number of hours, but the frequency of so then like an hour later in this case, the model runs again and it produces 3 hours, and so there's more hours produced by the model than there are, you know, than the spacing between the model forecasts. So how do you construct like a time series through this to compare with your data, say? And in fact, which one would you pick? There's different ways to pick that time series. So so basically, for this Coast Predict project, I took this one little model, which they're running in actually the arch of the boot in Italy, the Gulf of Toronto. So there's this little ocean model here, and basically every day it produces a data set. Actually, let me show you the. I'm going to scroll to the top of this notebook. The data sets themselves from the. So here I'm just opening up a netcdf file. This is one of the files, and it just has 144 time steps, just one time dimension, like you'd expect. But to make it work with this forecast model run collection stuff, you actually want to manipulate a little bit. So they wanted to keep their original files. They've got workflows that work with their original files. But what we did was basically just use virtualizar, open these things up as a data set, and then we have this little fix ds function here, which manipulates the time indices so that you, at the end of this thing, you end up with something that looks like, oh, sorry, I'm going to skip down to the bottom. You end up with something that has two time dimensions, essentially. One that's, 85 for each day that the model ran in this case, and 144 time steps. Okay. So that's what we wanted to end up with. And you can do that just by manipulating the indices. And then, so once we've got this thing, for each day, we can, from virtualizar, we can go to Icechunk and we can append to this existing data set. We can append along this time dimension, this now one per day. So each of these gets the steps that we just looked at. And then here I'm actually using something from the new Icechunk 2.0 alpha. You can amend a comment to just say that I'm adding this daily forecast. So you got a commit history that looks like this, where you have the initialization of the repo, and then you just have this one commit history where you've added your latest data set. So so this is all just on the provider side. So every day they run this script to push the data to the bucket, run this little script that appends to the Icechunk, and then the users can just go ahead and open up the Icechunk, and then they can use Rolodex to basically create this lazy time variable, and then specify that they want a data set at a specific best estimate offset. So in this case, I've said I want to create a time series that starts at forecast hour 7. And so he uses 7, until the next day's hour 7, and it goes forward like that. And so you can see right on the fly using this Rolodex tool, you come out with a data set that now has just a single time dimension called valid time. And then you can compare that to data, of course. And you might, so just, I don't know, scroll down here, and here we go. Here's some data that covers this dipping into all these netcdf files. And you might ask yourself, well, how'd you come up with 7, Rich? Well, the cool thing about this kind of stuff is that, you can easily, with this function, right, you can just go ahead and calculate the correlation at all these different offset, things, and see that, okay, at offset 0, which is the analysis period where you've ingested some data, so you can't use that one. Uh, that's the best, of course, but then it decays. And then, of course, it increases a little bit as you have some dynamic adjustment. And, in this case, somewhere around 7 or 8 hours is actually the best thing to compare. So that's pretty cool. And this is a super common use case, and it's made possible by Virtualizar, the Pangeo discourse forum where I found out about it, and all the other great stuff. So that's it. And well, and if you want to, find these notebooks, you can go to this Ocean Science Computing on GitHub and find my cloud school where I talked about this stuff. So thank you very much. Thank you, everybody.